So let's move on to section 1.2, transformations of parent functions. So our parent functions that you've dealt with so far are x squared and absolute value of x. And that's probably all we've tackled so far. So let's use this as an example. This is our general formula or our standard form, no, vertex form of a quadratic. That A, H, and K tells us things about where this thing is moving. So, for example, this is the parent function x squared, the quadratic. Starts at the origin, it's symmetric on both sides, it's our u. Now, if we mess with the k, which, if you recall, is this number chilling at the end of it, well, as k gets bigger, or as k gets smaller, it goes down. If k is positive, it goes up. So it's really what it looks like. However, when we look at, let me reset this. When we look at the h, which is the thing inside the parentheses, that tells us which way it's going, but it's the opposite of what it looks like in the equation. I was hoping to stop right there. But a is the most important part, the number right before the parentheses. Because if it's a larger number, our parabola gets narrower. If it's a smaller number, it gets wider. So bigger numbers, narrow, or a vertical stretch. Smaller numbers, compression, vertical compression. And then if it's negative, it reflects over the x-axis or flips upside down. That's where it comes down to it. So another way that we could write these same things using the notation that we have here is, say, g of x equals a times f of x, plus h plus k, not plus h, should be minus h. So these are the same things. They're just written differently. But the number in front, the a, tells us how wide or narrow it is. The h tells us up and down, or left and right, and k tells us up and down. But let's look at this some more. So in this function notation, if the symbol is inside the parentheses with the x, then the function is going to shift left c units. So if we have f of x as the absolute value of x, and g of x is the absolute value of x plus 1, well, that plus 1 means we move 1. However, because it's positive, and usually the equation is negative, we have to flip it, and we're actually going 1 to the left. Even though it's negative, oops. Yeah. So we moved left 1 unit. Now, the complete opposite for f of x minus c. If it's minus, we go to the right. Again, it's the opposite of what it looks like. So f of x equals x squared, g of x equals x minus 3 in parentheses squared. So that 3 is minus. So we moved 3. Even though it's negative, usually we think left, but it's to the right. It's the opposite. And we're going to be dealing with this same stuff the whole year. And it's going to have the same rules, so we need to remember these. Then we have the term outside of f of x, outside of the parentheses. And if it's plus c, we go up c units. If it's minus c, we go down. So that's exactly like it looks, the way it should be. So if f of x is x squared and g of x is x squared plus 4, not in parentheses, that just means we go up 4 units. The next one, f of x equals the absolute value of x. G of x is the absolute value of x minus 3. That minus 3 is outside the absolute value, so that's up and down. And because it's minus, we go down 3 units. Then our vertical stretch and compression, this deals with our a, the term in front of the f of x or in front of the parentheses, depending on how we write it. If a is between 0 and 1, so small numbers, it is a vertical compression. Means it gets wider. If a is greater than 1, then it's a vertical stretch. And these are larger numbers, and we get narrower. So if we're comparing f of x equals absolute value of x to g of x equals 2/3 absolute value of x, well, 2/3 is smaller than 1. It's a small number. So that means that we got wider. So we are 2/3, let's put it this way, a vertical compression, and then say the factor, 2/3. Whereas f of x equals x squared and g of x equals 3 times x squared, well, that's a vertical stretch because the 3 is larger than 1 by a factor of 3. It's 3 times as narrow. This is 2/3 times the width. And then reflection. If the negative's out front, in front of all of it, we reflect over the x-axis, or it's just upside down. So absolute value of x and absolute value, or g equals the absolute value, negative absolute value of x. Same for both of these, they both flip. And then this, we're not going to do. We don't do reflections over the y-axis. All right, so let's try some more examples here. So f of x equals parentheses x plus 2 squared minus 5. So the parent function is our quadratic. F of x equals x squared. It's everything, or it's the only numbers we see are the exponents, and we have an x. So now the 2 told us something about our transformation, and the minus 5 did. The 2 told us we move 2 units to the left. And it's the opposite of what you'd think. Positive 2, well, that's to the right. No, it's not. Not when it's inside the parentheses. It's the opposite. Now that minus 5 does mean we go 5 units down. So our vertex, again, is the opposite of that 2, so negative 2, and the same thing as that k, that negative 5 chilling at the end. Axis of symmetry is always x equals the x coordinate of our vertex. I'm not going to sketch a graph. G of x equals 3 times the absolute value of x plus 2. So our parent function is the absolute value function. That 3 tells us that we had a vertical stretch by 3. It's stretched because the number is larger than 1. And then we have that 2 units to the left again. It's the opposite of what's inside the parentheses. So our vertex is going to be -2, because again, that's the opposite of the +2. And there's no k. It's really +0. So our y-coordinate would be 0 for our vertex. X symmetry is going to be the same as our x-coordinate of our vertex. And we move on. H of x equals -x² minus 1. Again, this is our quadratic. F of x equals x². That negative over in front of it means there is a reflection over the x-axis. It flipped upside down. And that -1, it's not in parentheses, so we moved down 1. Our vertex is usually at 0, 0. The only movement we did was down 1. So our x-coordinate is still 0, but our y-coordinate is -1. And then x equals 0 is our vertex, because again, it's the same thing as the x-coordinate of our vertex. J of x here. J of x equals 2/3 times the absolute value of x minus 2 plus 1. So of course, this is the absolute value of x. That is our parent function. At 2/3, it's less than 1. So we have a vertical compression by 2/3. That 2 inside, a -2 inside the quote-unquote parentheses, our absolute value, means we move 2 to the left, and the 1 chilling behind it just means we go 1 up. So our vertex is 2, 1, and x equals 2 is our vertex, or our axis of symmetry. Okay, so now we're going to graph g of x equals x plus 4 squared minus 6 and its parent function f of x equals x squared. So we don't need to do this super hard way, but we need to graph x squared first. So if we were to put that into Desmos, we would get these points. Whoops, I think I screwed up there. Like that. So that's our parent function. Now, g of x, our transformed function. So what does that 4 tell us? It means we went 4 to the left. And that -6 after it means we went 6 down. So very simply, take the 5 points we just wrote, move them 4 left and 6 down from where they are now, and those are our new points. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And then we connected us. And we got our transformed function. And where is it? Well, it moved down 6 and it moved left 4, which is what exactly we said it did. So that makes sense, and the world is right yet again. All right, let's review some more transformations. So we really only talked about 2 functions, the square root and the absolute value functions. So this is what they look like when we're talking about transformations. The A is in front of the parentheses, or absolute value, which is kind of like parentheses. The H is inside the parentheses, but it's the opposite. And then our K is just a number chilling outside by itself. Remember, our A tells us if A is greater than 1, we have a vertical stretch. If A is less than 1, we have a vertical compression. And if A is less than 0, meaning negative, you reflect over the x-axis. So there's a lot going on with that first number. If you don't see a number, what number is it actually? 1. So that's our default. The h, it is the opposite of what it looks like, and it tells us left or right. And then finally, k, our number chilling at the end, is up or down, and it's exactly like what it looks like. If it's positive, we go up. If it's negative, we go down. All right, so example 1 here. Describe the transformations on the parent function of f of x equals x squared to get g of x. Where's the vertex and the axis of symmetry? Okay, so the only thing that changed here was the 2/3 and that plus 1. The 2/3, because it's less than 1, tells us we have a vertical compression, meaning it got wider by 2/3. And that 1, that plus 1, tells us we went 1 to the left. So our vertex is at -1, 0. Axis symmetry is x equals -1. Don't forget the x equals. Otherwise, it's just a number. It's not a line. Move on to b. G of x equals -x squared minus 7. So we got the minus to deal with and the minus 7. So the negative means we have a reflection over the x-axis, meaning it flipped upside down. And that minus 7 chilling at the end means down 7. Now letter C has 3 transformations. We got a 3, we got a 5, and we got another 3. So the first 3 is a vertical stretch by 3. That 5 on the inside means we move 5 to the right because it's the opposite, even though it says minus. And that 3 is the last 3 is exactly what it looks like. It's 3 up because it's positive. Oh, we forgot to do our vertex and our axis symmetry for the last 2. This would be 0, -7, and x equals 0. This would be 5, 3, and x equals 5. All right, so now we need to graph these functions, find the vertex and axis symmetry, and then we'll write some equations and we'll call it a day for the unit. So we got f of x equals -3 times x plus 4 squared. The negative is something, the 3 is something, and the 4 is something. We have 3 transformations. We have a reflection over the x-axis because of the negative. We have a vertical stretch by 3 because the 3 is greater than 1. And we're moving 4 to the left. It's the opposite of what it looks like. It's positive 4, so we go left. Our vertex would be at -4, and we didn't go up or down, so it's still at 0. And our axis symmetry is x equals -4. Now, we have to graph this. What's the easiest way to graph it? Well, very simply, put in decimals. Get some points, call it a day. So f of x equals -3 times x plus 4 squared. And did it reflect over the x-axis? Yeah, it's upside down. Did it get more narrow, vertical stretch by 3? Kind of looks like it. Did it go 4 left? It sure did. So that's what we want. But let's get some points so we can make it nice looking. So we hit the gear and then the table. Now those values are not nice looking because they're all the way down here. We need them here. So I'm going to substitute in -3, -4, -5, and -6. And those should be good enough points to graph. So -3, -3, -4, 0, -5, -3, -6, -12 wouldn't work on there. I think that's all we're probably getting. So kind of make it a little bit rounded more. Not a V, but a U. But that's how we graph that. Moving on to letter B. We have a transformation from the 1/4 and the +2. So the 1/4 is a vertical compression, meaning it got wider by 1/4 and 2 up. Now our vertex is usually at the origin. We didn't go left or right at all, so we're still at 0, but we did go up 2, so we're at (2). And our axis of symmetry is x equals, well, what x equals? Now we just have to get out our good friend Desmos yet again so that we can graph this. I'll get rid of that, and that. You need to see the equation. So we got f of x equals 1/4 absolute value of x plus 2. And that's what it looks like. Did we get compressed by 1/4? It definitely looks wider. Did we go 2 up? Yep. So now let's get some points and graph them up. So the gear, hit the table. These aren't very nice, but that's what happens when we make it a compression. So -2, 2.5, -1, 2.25. So it's very, very wide and looks something like that. Now, we can also go the other direction. They can give you, or we can give you the transformation. You got to write the equation. So we want to write it for g of x, given that f of x is the absolute value. So g of x equals space, absolute value, x, space, space. Then all I have to do is substitute in numbers. So it's a vertical stretch by a factor of 4. Vertical stretch, well, that's the number out front, so it's 4. Horizontal translation left 1. So it would be -1, but because it's the opposite, it's actually +1. And then that's it. We didn't go up and down at all. Letter B, again, I'll do g of x equals absolute value of x. And now all I have to do is put in the numbers. Reflection over the x-axis means it's negative out front. Vertical translation up 5, so that's outside our parentheses, and it's +5 like it looks. You could put a -0 in there, but you don't have to inside the absolute value bars. And then lastly, g of x equals absolute value of x. We got a vertical compression by a factor of 1/2. 1/2 is our coefficient. Horizontal translation right 2. So it's -2 because it's the opposite. And down 3, that's exactly what it looks like. And that is -3.